Hello, today we're going to be continuing with the writing equations theme. And today, except for the only difference is we're going to add in some different application problems today. So as always, you guys know the drill. Before we start, if you guys could try the problem at the top of the page. One thing that I will remind you guys about, I'll help you out with some of the formulas. Just remember that just in case you need it, we have slope formula, which is y1 minus y2 over x2 minus x1. I don't know what I said. The top should be y2 minus y1 over x2 minus x1. Good. And just in case you need it, slope-intercept form is y equals mx plus b. And point slope form, which was the new one we learned last week, y minus y1 equals m times x minus x1. All right, guys, pause your video now and give this one a shot. All right, answers are up. Your first step on this one, remember when writing any equation, you really need to know two things. You need to first of all know, I'll write it up here. First of all, you need to know what the slope is. So if you don't know what the slope is, then that has to be your first step. You can't write the equation of a line with no slope. So for this one, the great thing was they gave me 2 points. And to figure out the slope between those 2 points, we're going to use our handy dandy trusty slope formula. So all I did was I labeled my points. So it's going to be y2 minus y1 over x2 minus x1. And then it's really just a matter of simplifying. 9 minus 6 ends up being 3. And 4 minus 1 also ends up being 3. So when I divide them, 3 divided by 3 ends up being 1. And we're left with our slope of 1. Okay, now next step is to actually write the equation. Now, to write the equation though, we found our slope, but we need to know something else, and that is at least a point. Now, if you're given a y-intercept, you can go straight into slope-intercept form, because then you know a slope and an intercept. But if you don't actually know your y-intercept, and I know I don't because neither of these are an x-intercept. An x-intercept only has a 0 written in the first spot. So if that doesn't happen, that just tells me I can't go straight to slope-intercept form, and we have to start by going into point-slope form. So that's what I did. Point-slope form, the cool thing is you could have chosen either one of these points. I happen to choose the first point. So if you plug in your slope of 1 that you just found, plug in your y-coordinate, which was 6, your x-coordinate, which was 1. So I chose the first ordered pair, by the way. It's just really a matter of simplifying. We're going to distribute the 1 to each of those pieces. So 1 times x is going to be 1x. 1 times 1 ends up being 1. Or negative 1, I should say. And then your last step was to add 6 to both sides. And you're left with your final answer of y equals 1x plus 5. Okay? And that process honestly really doesn't change all that much. Now, except for today, because when we write equations of word problems, here's the goal. The goal is I'm going to basically give you a description of a scenario, and we're going to write the equation of that line. So the first example that we're going to talk about, let's read it. So it says a cab company charges a $3 boarding rate in addition to its meter, which is $2 for every mile driven. So I don't know if you guys know how cabs work, but this is usually pretty standard. Usually there's like a minimum fee, which is like what they call the boarding rate. Just means the price that it costs to just ride in the cab. And then they're saying that it's $2 for every mile driven. So let's think about that equation-wise. I know for a fact it says use y to represent the total cost, which makes sense because that's actually what we're dealing with, right? Everything isn't dealing in terms of money. So at the end of the day, at the end of this cab ride, that's the thing that we want to know. Now, the rest of this though, let's see where we would start. So it says a cab company charges a $3 boarding rate. And that's just the minimum fee. So really what they're telling us in this problem is they're telling us the starting place. That's the starting price, which is just like our starting point, which just means they're telling us what the y-intercept is. whatever the number is that's not really going to be changing all that much, that's the number that that's always going to be our y-intercept. It's kind of like right when the situation first starts occurring, how much do you know you have to spend right off the bat? And in this case, we know we have to spend $3. Now, obviously, we're going to spend more than that because it says it's $2 for every mile driven. Well, what would we do? We would take the amount of money that was here, and really it kind of depends. If we were to drive 6 miles and it's $2 for every mile, ideally what we would do is we would multiply those two guys together. In this case, though, because it's $2 per mile, what that's telling us is the slope. It's $2 per mile driven, which makes sense because they told us that X represents the number of miles. So whatever kind of the piece that's changing is, that's usually going to be your slope. It's the something per something else. It's kind of your hint. Now, one thing that I'm not going to make you guys do, just so you guys are aware when it comes to graphing, I'm always going to fill in the scales. So I filled in the scale that we're going to be using for today. So first thing we're going to graph, it's 2x plus 3. So really what I'm going to do is I'm going to start up at 3 on my graph. So I'm going to start here at 3. I counted by 2s, so just make sure that all the odd numbers are kind of halfway in between those. And we're going to basically apply our slope. So I'm going to rise 1, 2, and I'm going to run 1, and there's my next point. And pretty much you can probably notice a trend. If I rise 2, I hate when it does that. I'm going to rise 2, run, nope, 1, there's my next point. And you can probably start to notice your trend. If I start filling in all my other points, my next point, rise 2, run 1, is going to be here. Rise 2, run 1, here, here, here. And we can now fill in our line. So for this particular one, we're going to start at 2, and we're going to go all the way. That did not work, but it works okay. And it's going to go off into the distance. So the cool thing about this is, for part B, it says we did graph it, but it also says label the axes. So if we want to label those, it pretty much just means we're going to fill in what X and Y actually represent. So up in the directions, it says X represents the number of miles driven. So that's what my X-axis represents, number of miles. And what does Y represent? Well, Y represents the total cost. So that's what I'm going to fill in on my value, which I can't do it. Total. I'm writing sideways, guys. I'm so sorry. That was not that bad, actually. But my y-axis is going to represent the total cost. So keep in mind, that's what all of your points recognize. Since it's always x comma y, right? It's always, all of these points just have, again, that deeper meaning. It just means that X represents the number of miles and Y represents the total cost. So if you look at part C says how much does it cost to ride in this cab for 1 minute? You can really do this one of 2 ways. You can use the equation, because if I know that I'm riding for 1 minute, oh, actually pause for a second, guys. I'm sorry, it should have said for 1 mile. Ooh, change that right now. That makes no sense. I was like, time isn't involved. So it says, how much does it cost to ride in this cab for 1 mile? What they're telling us is X, because X represents the number of miles. So one way you could go about doing this is you can plug it into the equation. You know it's $2 per mile. So if I'm only riding in this cab for 1 mile, I'm only spending $2 on that. But I still have to add into account how much I'm spending for just getting in the cab, right? Which was 3. So how much does it cost? Really, it costs $5. Now, you could have also used all of your good hard work. You guys already graphed this, right? If you wanted to say, okay, well, what's happening at 1 mile? Well, let's look. What's the Y value on that point? Oh, it's at 5. So you could have found it from your graph. If it's a pretty nice graph, sometimes it's a little bit hard to tell. The solving using the equation is a little bit nicer sometimes, just because it gives you an exact answer. But sometimes like for this one, if your points fall in a pretty nice progression, then that's something that's pretty nice to do. Now, we probably should have done this right off the bat, but again, this question is something we're going to ask a lot. It says, what does the slope of the line represent? Well, let's start off with, well, what is my slope? My slope is 2/1. And for any slope, whatever number is on top represents the y's. We took 2 points, whatever they were, and we subtracted their y values and got 2. So if my y values are the ones that are on top, and y represents the total cost, then what this really means is it basically costs $2 for every 1 mile, which we kind of already knew. But really at the end of the day, when I say, what does this represent? That's basically what you're going to tell me just in words. It costs $2 for every mile. I want to say driven. Yep. It costs 2 miles for every mile driven. And part E is my favorite, because if we know that 3/9 is a point, and it actually is, if I go over 3, I actually do go up 9 to reach that point right there. That makes sense. That just means, remember, X is the number of miles driven. Ha-ha, right there it tells us. And Y represents the total cost. It tells us there too. It just means after 3 miles driven, it will cost, ooh, not uppercase. Oh gosh, guys, I'm sorry, I can't write. It costs $9. Alrighty. So what I want you guys to do, I want you guys to pause your video and I want you to give example number 2 a shot. Nope, not example number 2. The next you try now. So pause your video and give this one a shot right now. I forgot. Before you guys go, I'm actually going to fill in the graph values just so when you get to that question, you can go ahead and graph it. So there you go, guys. So if you need to, you're going to use these values to graph your line when you get to part B. All right, guys, pause your video and now give this one a shot. All right, answer is up. Your equation, now you could have written this one of 2 ways. Either way for this one, your starting height of this plant ends up being 60. So if you wrote that on the end, that's totally fine. And at the end of the day, you have to be careful though, because it says the plant is basically getting 5 centimeters shorter every month. So because it's getting shorter, that means that our slope on this one is going to be negative because it's going down. So if you, I'm going to kind of skip ahead of just a little bit. If you look at question D where it says, what does the slope of the line represent? That basically tells you, the plant loses 5 centimeters every month that it's alive, which is kind of sad. That means this one might be a dying plant. I don't really know. But so either way though, for part A, either way that you write your equation, either one of these is fine. The top one is in true slope-intercept form, but that part doesn't really matter all that much. So next step then is part B where it says graph the equation. So obviously I started at the starting point. I started at 0. The plant was 60 centimeters to start. And my slope tells me I'm going to go down 5 every month. So I'm going to go down 5, right 1, and that's where I plotted the next point, and so on and so forth. So if you graphed it correctly, you should have reached it should have reached 0 feet high at 12 months. It's kind of sad that this plant only lasts a year, but that's okay. So for the purpose of this one, that just means for when I said label your axes, I told you in the equation what they should be. It says let the x-axis represent the number of months and let the y-axis represent the height of the plant. So for part C, it says how long would it take for the plant to grow 45 centimeters tall? You could really do this one of 2 ways. Some students might if you went to where it was 45 centimeters tall, which is right here, well, it takes 3 months for you to get there. You could have also gone the plugging in the equation route if that was you. You could have gone up here and plugged in 45 into the y value and solve for x. You could have done that as well. But in this case, the graph was a little bit easier because it was right there. And last but not least, question number E, letter E says, what does the 0.820 represent? Well, all of my points, the x value represents the number of months and the y value represents the total height. So it just means after 8 months, the total height of the plant is 20 centimeters. Now there's one other type of word problem that we're going to deal with, and it's one where you might not necessarily be given a straight up slope. So let's read the example 2. It says Sam wants to cater buddies for her friend's birthday. She wants to order thin crust pizzas, which cost $13, and deep dish pizzas, which cost $18. She spent a total of $191 on her order. So this one's kind of odd because usually the total is always the thing that we don't know. In the last example, we didn't know what the total height was. So that made y was alone on one side. So that's why we had a variable on that side. But in a problem like this where we said Sam wants to cater buddies for her birthday party, it doesn't tell us that. It tells us the total. So if you're given a total, we know for a fact that that's going to go on one side by itself. And it just means now if we keep reading, it kind of gives us a hint. It says let x represent the number of thin crust pizzas and let y represent the number of deep dish pizzas. So what we're going to do is we're going to place those variables with those prices. It tells us that thin crust pizzas cost $13. So 13, it would be times the number of thin crust pizzas, which just is represented by x. And then to add to that, we would add to that whatever we would spend on deep dish. And deep dish, it's $18 per deep dish pizza. So this case, our equation looks a little bit different, but I'm not actually asking you to graph it. You don't have to convert it into slope-intercept form. We're just going to use it as is right now. So we're going to say, all right, part B says, let's say her budget changed to $200. So instead of 191, it's going to change to 200. And it says, if she buys eight deep dish pizzas, how many thin crust pizzas can she buy? Well, deep dish pizzas are represented by Y. So let's go through and plug that in. We know for a fact there's 8 of these guys. So let's see how many thin crust pizzas we can order. So we are going to start by multiplying 18 times 8. And that's going to leave us with 144. I'm going to bring everything down. Now to solve for x, my first step is really just going to be to, I'm going to zoom in a little bit, I'm going to subtract 144 from both sides. So if you take 200 minus 144, we're going to be left with 56. And our last step to solving is really just dividing by 13 to get x alone. Now this is a case where if you look at this, you're going to notice that this answer kind of doesn't make any sense. It says you can buy 14.31 pizzas. And hopefully in real life you're thinking, well, Miss Hardy, is that even possible? Absolutely not. Now you're probably saying, well, how do we choose? Can she buy 3? Can she buy 5? Can she buy 4? Well, this means she can buy as many as 4.31. Now, can you buy 0.31 of a pizza? No, you have to buy a pizza or not a pizza. So for all intents and purposes, we're just going to cut off the decimals. It just means at the end of the day, she can buy 4 thin crust pizzas. Final answer, we're going to add in our units and we are done. Now part C, we're going to kind of work with the same thing. It says, let's say the budget was still 191. So okay, her budget was back to normal. For some reason, I don't know, maybe she was working out what she wanted to buy. So here it says it's still 13x plus 18y, but It tells us that she definitely buys 9 thin crust pizzas. How many deep dish pizzas can she buy? Difference here is that she's buying a thin crust pizza, and X is the number that represents the thin crust pizzas. So I'm not going to plug it in for Y on this one. I am going to plug it in for X. And we're going to solve. So that's what I want you guys to do. I want you guys to pause your video, and I want you guys to solve for Y. All right, final answer. You should have got Sam could buy 4 deep dish pizzas. Now, how do we get there? First step was you should have multiplied the 13 and the 9 together, and you got 117. And then to solve for Y, we're going to start by subtracting the 117 from both sides. And then last but not least, dividing both sides by 18. You actually do get a decimal on this one as well. You get 4.11, but again, you can't buy 0.11 of a pizza. So we can't buy more than that though, because that would cost more money. So the only thing that she can buy is just 4 deep dish pizzas. All right, guys, that's it for today. You guys can exit the video and you can start working on the homework.